Okay, so we are going to be in Chapter 11, Section 4. We're going to talk about empirical formulas. So an empirical formula is the simplest way that you can write a chemical formula for a compound. Now, the molecular formula is based on how many atoms it has. So you can have a compound that can have a different empirical formula than a molecular formula. The empirical, again, is just the most simplified version of that formula that we could possibly come across. And so let's work on this. So we're going to do percent composition based. So we did percent composition, and so that's already been determined here. And so we are going to figure out, based on this percent composition, how much we have. So let's just do this. Since everything's out of 100%, let's just change this percent sign here to grams. And so that's basically the easiest way that we're going to be able to do this. And so when we start going through, oops, went down too far. We're to take 48.8 grams, so we're changing percent to grams of carbon. And we're going to do the first step, and that's going to be converting grams to moles. Okay, so this step's easy. So we're going to take 1 mole of carbon over the molar mass, which is 12 grams of carbon. We're just going to solve. So you get 4.067 moles. Okay, so now we're going to do that for the other two. So we're going to take hydrogen. And again, if you know I made a mistake on the first one, it should be 8.16, not 81.6. So we're going to have 8.16 grams of hydrogen. 1 mole of hydrogen equals 1 gram hydrogen. And in this case, we're going to get 8.16 moles hydrogen. Got the right carbon up there. Okay, so now we're going to do the same thing for oxygen. So we have 43.2 grams. Remember, percent is changing to grams of oxygen. 1 mole oxygen. 16 grams. Again, this is coming from the periodic table of elements. We get 2.7 moles of O2. So now that we've done that, we have our 3 substances here. Let me shrink this down just a little bit so we can see all 3. So we have our substances right here. And we are going to determine which one we are divided by. So we want to find the smallest number of moles. So obviously 2.7 is our smallest number of moles. So what we're trying to do is we're trying to go and determine the chemical formula for this compound. And so in this case, we're going to take the smallest number of moles and we're going to divide it by all the other ones because we're trying to get whole numbers here, because you can't have 2.7 moles of oxygen and put that into a chemical formula. It has to be a whole number. So we're going to take the smallest one, divide it out. So let's take our 2.7. And what we do to one, we have to do to all. So we're going to take 2.7, we're going to divide it by all of these. And again, what we're trying to get is whole numbers here. Okay, and so in this case, 2.7 divided by 2.7, that's 1 mole of oxygen. Okay, so we're going to take, and here we get 3.02 moles of hydrogen. And in this case, we get 1.5 moles of carbon. Well, we could round these, but this is not going to round to a nice little number. So what we want to do is we want to find a number that will go into all of these here. So I'm going to rewrite them down here so we can actually see this. So we've now divided by the smallest number, and we get 1.5 moles of carbon. We got 3.02 moles of hydrogen, and we have 1 mole of oxygen. What we're trying to get is whole numbers. Well, we could round this here to simply 3. That would make sense. However, that does not make up for a 1.5. So what we're going to do is we're going to take the smallest number that we can multiply this by to get a whole number. So 1.5, we can multiply that by 2. And that gives us 3 moles of carbon. Well, if we do it to 1 here, we now have to do it to all of them because we can't just leave them out. So what you do to 1, you have to do to all. So in this case, you have 3 moles of carbon. So now we have to take 2 times 3. We get 6 moles of hydrogen, and we have 2 moles of oxygen. So how does this translate to a chemical formula, you're asking me right now? Here's what we're going to do. We're going to put the elements in order. C, H, and O. 3 moles tells us that we have 3 carbon atoms. We have 6 hydrogen, and we have 2 oxygen. This is called an empirical formula because this is the simplest form that this can be in. It can't be reduced down. Now, the molecular formula might have something like this multiplied by 2, giving us 6 carbon, 12 hydrogen, and 4 oxygen. But in this case, we are in the molecular or empirical formula. This is the simplest version of this. And so this is going to be our answer right here. And so this is how you get the empirical formula. So this, because it takes so long to do, this video will be broken up into different sections. So this is the first deal. This is turning empirical formula from percent composition. This is where you're figuring those out. Remember, when you do percent composition, you're simply taking those percents and turning them over. So let's try one more. So again, here we have our percent composition of the 2 elements. So we're going to take our 36.11%, turn that to grams of calcium. First step, convert 2 moles. So we have 1 mole of Ca here, and that's 40.1 grams of Ca. Solve that out. You get 0.9 moles of Ca. Don't convert quite yet to a whole number. Then we're going to do the next one, and so we have 63.89 grams of chlorine. And we have 1 mole chlorine over 35.5 grams of Cl, which gives us 1.8 moles of Cl. Divide by the smallest number. Okay, so that's going to be 0.9. 0.9. Okay, so in this case, this equals 1 mole of Ca. And when we divide this out, we get 2 moles of Cl. Hey, good news, you guys. We're in whole numbers here, and we're in whole numbers here. We didn't have to go rounding crazy for it. And so because we're already in whole number form, we don't have to multiply by the smallest number or number to get a whole number because we're already there. And so the chemical formula for this would be Ca. Well, you have 1, so you don't have to write a subscript. And Cl2, 2 being the shortest subscript. Okay, you can look at the next problem 3 on the additional problems